Hi guys, and welcome to Learn Extra Live. What is today, guys? It's life science and it's grade 10. So I hope that you're all tuned in. You've got your eyes peeled to the screen and you join us on www.facebook.com/Learn Extra. You can also chat to us on Twitter @Learn Extra. I'm Indy. I'm here to help you with any questions you may have. If you're struggling with anything, guys, please post it onto the page. Also help each other out, because don't forget that this is a community of mind-setters. It is all about helping, inspiring, and motivating each other. So grade 10s today is organic compounds. It's all about food tests. We've got Jürgen in studio with us today, and we're going to be doing some experiments. So today's show is going to be quite exciting, quite different. So we want lots of interaction. We want lots of questions and lots of energy, because that's what it's all about. It's about making learning fun. And learning really is fun. So now, guys, just in case you haven't seen yet, we have chosen our top 10 presenters. Keep your eyes peeled to the page, and it's 319 for more information on when you'll actually be seeing these new guys here in studio on Learn Extra Live. We are so excited and we are so proud of all of you guys. But that's going to be happening next week. And I think Jürgen is itching, chomping at the bit to get going with his experiments. I can see he's moving on his little things. And let's go straight to him. Jürgen, up to you.
Thanks, Indy. Good afternoon, guys. And as promised last week, guys, we're going to look at some of the experiments on organic compounds. Now, just to briefly chat about what we did last week. Last week, we looked at the organic and inorganic compounds, and then we discussed a bit about what the inorganic compounds were, and I said it's important to remember the source and the abnormalities or the deficiency syndromes that arise from a deficiency in an inorganic compound. Today, we're looking at the organic compounds, but we're looking at specifically testing for the presence of organic groups in different food samples. So what we have here today is I'm probably going to do about 4 experiments by the end of the session. So we're going to have a power-packed session of 4 experiments where we're going to look at different food samples and we're going to test them out. Just to very quickly flash back, we discussed the 4 groups last week. We said they were proteins, they were lipids, they were carbohydrates, and obviously we looked at the vitamins. Today we're going to be testing for proteins. We're going to be testing for the presence of lipids in different samples. We're also going to be doing a starch test to test the presence of starch, as well as we're going to do the glucose test to test the presence of glucose. So what I've set out today here in front of me is I've got different food samples that I've prepared, and here you see that there's a glucose sample. Here we've got a starch solution. I've got some grape juice in here. We've got the milk that we normally have with our coffee and tea, and here I've got an oil sample that we use at home for cooking, and here I have an egg solution, obviously prepared from egg. Now, at the start, I'm not going to actually mention to you what these would contain, but we know that there are proteins, there are carbohydrates, and there are fats in these different food samples. We also have, later on in the episode, we're going to look at the nutrition, the nutritional value of having peanuts and different types of nuts and why they're important to us. So let's start. Right, so today the first test we're going to look at is for the testing of glucose. And guys, when we test for the presence of organic compounds, we need to have a reagent. A reagent basically is an indicator. It's a mixture of a few chemicals that will react with the chemical group and it'll produce a color. And essentially what we're looking for is we're testing for the presence of a protein or an organic compound, and that could be indicated by the presence of by a change in color or by the absence of a typical color. So when we look at any food test for glucose, we normally test for the presence of glucose using a reagent known as Benedict's reagent. Now guys, you probably would have seen other reagents that you work with, but we tend to use lots of Benedict reagent as easy to use. It's very quick and we get results very quickly. You would need to have some boiling water, and remember guys, whenever you're doing an experiment, you gotta take the necessary precautions. You don't smell any of the contents, you don't sniff out any of the contents, you don't taste anything that you have, and that's important. And ensure that your windows and your rooms are well ventilated. And always guys, do an experiment when your teacher's around, so that if something goes wrong, your teachers know exactly how to correct them or how to react in a situation. So let's start. So what I have here is I've a set of test tubes, and I've labeled them glucose, I've labeled them water, grape juice, milk, and this is egg solution, and here we have a starch solution. So what we're testing for in the first test, guys, is the presence of glucose in different food samples. And if you'd notice, the first test tube is a glucose test tube, the second one is a water. And we call these the positive control and the negative control. And the reason why we have these is because in order for us to know what the color change is of a substance that contains glucose, we would need to have glucose in that series of experiments. So we have a positive control as well as we have a negative control, which is water. So we're going to throw in 2 mLs, guys, into the first test tube, and that is glucose that goes into the first test tube. We're then going to add our negative control, which is water. We're going to add in a similar amount, and we know that water does not have any of the carbohydrates in them. It's an inorganic molecule, and hence this is our positive control and that's our negative control. And so this would be used to compare results against the others. The next tube is labeled grape juice, and so we're going to throw in some grape juice in there, and we know that grape juice is sweet, so we're expecting some results here, guys. So I'm going to put in about 2 mLs of grape juice into that test tube, and then we're going to add in some milk, guys. And we know what the value of the nutritional compounds in milk is, but we're not going to guess yet. And let's see if we get results that we anticipate. So that's milk that we've put in there. And the next one is an egg solution, guys. And I know that eggs are very important. They're important as a source of protein, and hence you know why that's in your diet. So it's very important to sustain your protein needs by having lots of eggs. And obviously the last one is a starch solution, guys, and we know the value of starch as well. We see that coming from your potatoes that you eat. Let's look at these now. So we've created now a series of 6 test tubes, and the important thing is to make sure that you've got your test tubes labeled. We're then going to add in an amount of Benedict's reagent, which is what we're going to add. We're going to try and add in about 2 mLs of Benedict's reagent into each one of these. Okay, that's Benedict's reagent into the first one, into the second one. And while we do this, guys, I've got a kettle that's boiling, and that's obviously, I'm going to put these test tubes into the kettle and allow them to stand for about 15 minutes. And while that happens, we're going to start with the next set of experiments. We'll be testing for the presence of proteins in different food samples. So now we've added Benedict's, almost 2 mLs into each one. Indy hopes that nothing's going to blow up today, but I doubt, because we're using all organic compounds and we're not using anything that's combustible yet, because we get to ether, and that's, so we're going to give this a gentle stir, and we're going to look out for a color change. Now, the color indicator when using Benedict's reagent, guys, is a dark orange-red precipitate that will develop at the bottom of the test tube, and that would indicate a positive change. But these test tubes would need to go into a water bath. And there's a reason why that they go into a water bath, and that's important to understand. Remember that reactions are speeded up when we provide heat. And to speed up the rate of the reaction and provide the energy for the reaction to take place, we're going to immerse these test tubes into a beaker filled with hot water. So I'm going to quickly grab the kettle for you guys, and I'm going to put in these beakers into a kettle filled with boiling water. Guys, again, you've got to be very careful and very cautious when using hot water. Remember that dangers, accidents can always happen, and you've got to be very careful. We normally will use a water bath at school, but I know that we all may not have a water bath. There's a bit too much of water in here, so I'm going to drop out a bit. Okay, we just need a wee bit, and obviously that's causing the test tubes to jump up and rise a bit. While this incubates, I'm going to move on to the next experiment. So here you see them right in the front here, guys, and you're going to watch out for color changes. And obviously, because these have been mixed up and not in a test tube, you're not going to know. But it's going to be interesting after a little while, probably about 5 minutes, when we see some color change. And if you look carefully, guys, we're seeing some color change already. Let's not interpret those results now. Let's move on to the next experiment, which is testing for the presence of proteins. And remember that proteins also needs to be, the reaction needs to be supplied with heat so that we can speed up that. Whilst these happen, we're going to look at, whilst this reaction continues, we're going to try the experiment out for the presence of proteins. So again, I said that when we test for the presence of compounds, especially organic compounds, we need reagents. And the reagent we're using here is Fellings A and Fellings B. Now these are 2 reagents, and so it's obviously a blue color reagent, and if you guys did chemistry a bit, or if you started, you know that a blue color reagent normally contains copper sulfate. So this is a copper sulfate solution, and here we have a solution that's sodium hydroxide, and when they react together in the presence of proteins, they would produce a color. And I'm going to wait for the color to develop to actually show you the color. It's actually very intense, and it's nice, especially as we see the different intensities change. The concentration of proteins will influence the color and the intensity of the color. So remember, I said that the reagent we're using is Benedict's reagent, guys, and it's of two reagents, of 2 bottles. Here we've got copper sulfate and we've got sodium hydroxide. Again, I've got a series of test tubes labeled for you. The first test tube is called a protein solution, and the second one a water test tube. And the reason why we do this in any experiment is to identify the positive control and the negative control. And as I mentioned, the positive control will always contain the substance we're testing for. The negative control will be water that does not have the proteins. So by looking at these two, we can compare these results to the rest. So let's get busy. So the first one is a protein solution, and in that, I know, guys, that milk. So I've got milk here. I'm going to add in milk into the test tube that says milk. I'm going to jump to the milk straight away. I'm going to go on to grape juice, and let's try some grape juice into this test tube here. So we're putting in some grape juice in there. We're going to also try to see the presence of starch, proteins in starch. So we've got starch. Put that in there. Okay. Then we go on to our egg solution, which is here. And we're going to put that in there, guys. And we have one more, which is water, and I'm going to put in water in there. And I must also add the protein control, the positive control, into there. So now we've added the different substances that we're testing, and it's now time to add the reagent. And as I said, the reagent we're looking at is fillings A and B, so I'm going to add approximately equal quantities of fillings A into each one of them. And while this happens, guys, I want you guys to focus on these as well. Why I do the additions and dilutions in here? And you'd notice that the glucose test is giving us some positive results already, and some beautiful colors and different. So we got to interpret those after we put this to react for a little while. So I'm going to add the other reagent, which we're looking at is fillings B, and this is sodium hydroxide, guys. And immediately we're seeing the presence of a color change. We're going to interpret those results very, very quickly. I think it's important for you guys to understand and interpret the results more than to admire the colors, because it's important. There's some fantastic colors that we're going to get here. But what is interesting is how do we interpret these results? And that's fundamentally important, to interpret them correctly. I know you guys would probably try this during your life science lessons at school. And it's important, guys, to again be cautious about how you use chemicals, never to leave these bottles lying around open in the class, and ensure that your teacher's around when you're trying different experiments. And never mix chemicals that you are not familiar with, because that could lead to serious problems, because you may not know how they react. So I'm going to again put these into a beaker. We actually don't need to do that, because here we clearly see reactions taking place. So fortunately for us, guys, today we don't need to stimulate the reaction by adding in heat. We've got results instantly, and I'm going to very quickly look at how much time we have for a break, and then probably we're going to look at and interpret these results when we get back.
Okay, I think it's time for a little break. Guys, if you don't know and if you haven't seen the post on our Facebook page, you can get today's show notes. Whatever we're going over now, you can download them to your phone, you can print them out, and you can work along with us. And the link to that is www.mindset.co.za/learn/extra/live. And what that link will take you to is also an entire schedule of all of the shows. You can download the show notes, and then in 3 days' time, we will be uploading this very session onto YouTube. So this is the link to know, this is the link to go to for all of your needs. We'll see you now after the break. Hi guys, and welcome back to Learn Extra Live, grade 10s. I hope you are tuning in for life science and you've downloaded those notes. There is actually an easier, much easier URL, which I'm going to give to you right now. It is learnextra.co.za/live. That's it. That's it. Okay, if you just saw in the ad break, you would have seen the Pay It Forward campaign. And what we want you to do, guys, this is a Facebook competition where we want you to post pictures onto our page. That's www.facebook.com/learn Learn Extra. And what we need you to do is post pictures of you paying it forward. This is the month of love, so that's what we want you to do. So whether it's a picture of you helping your mom carry in the shopping, helping your brother do his homework, helping the lady down the road, I don't know, carry bags. That's what we need you to do. But you can check our Facebook page, and what we will be doing is from next week we will be giving away amazing hampers and amazing prizes. So I can see Jürgen's getting ready with his experiment. He's nearly done setting out everything on the table, and I indeed have seen a few changes in those little vials. So Jürgen, what has gone on there in those protein and glucose tests?
So Indy, as I said, we needed some time for the reactions to take place. We've got 2 tests that we did simultaneously. We're testing for the presence of proteins, and we're testing for the presence of glucose. Remember, guys, we used Benedict's reagent for the presence of proteins, and we're using for the presence of we use Benedict's for the presence of glucose. I'm going to just turn that over here, and we use Felling's A and B. Now, it's very important for us to interpret the results, and this is how we're going to interpret them. So the first test, which is glucose, we used a positive control, and in this test tube we used glucose. And obviously this is the positive test. So it's given us a nice, if you look at this, guys, it's given us a nice brick red precipitate that actually is beautiful. It looks nice and red, indicating a strong presence of glucose. Then we tested for the presence of water, whether it had any glucose. And if you clearly look at this, guys, in the water there's no glucose. So we can look at these as our 2 test tubes to compare, and that's why we call this the positive control and this the negative control. The first sample we tested, guys, was grape juice, and we looked at the color, and if we compare this to glucose, again, guys, you can clearly see that a similarity in color, a tinge of orange in it, not as dark as this, indicating, yes, a positive test for glucose. So we tested positive glucose in the grape juice. When we looked at milk, guys, and really not a specific orange color, but it's got a greenish tinge indicating the absence of glucose in milk. We then tested starch, and we know that starch is a polysaccharide, and it's not glucose, which is glucose is a monosaccharide, and hence this tested, if you compare that to the positive control, tested negative, indicating the absence of glucose in starch solution. And then finally we looked at the egg solution, and if we looked at this, guys, it's already solidified, because remember we put it into boiling water and the protein agglutinated, it became thick, and hence it doesn't. But again, a negative change in this. And if you're often battling to have a look at the color, you must always use a background that is white. So if I place this tile clearly behind here, you can see these colors are very, very enhanced. Okay, so these are the results. We're going to look at these results. I've tabulated the results for you on the smart board. We're going to get to that in the last session. Let's look at the results for the protein test. Again, we used Benedict's A, and we used Felling's A and B for the presence of proteins, and we tested using a positive control, which is a protein sample, and here we clearly see a dark purple color. Isn't this beautiful, Andy? Look at this beautiful purple color.
It's my favorite color, in fact.
So you can see it looks very nice and purple. And the amazing thing about the intensity of the color will tell us the concentration of proteins. And just by looking at this, guys, you can see that we've got shades of purple. Here we've got milk, which is a lavender color, not exactly a lilac color more. I'm not very good with colors, you can see that, Indy. But yeah.
Lilac was good.
Okay. And here we've got water, which obviously does not contain protein, and you can see that in the presence of the reagent, water remains, the color of the reagent remains blue, indicating the absence. So anything else that has a blue color would indicate the absence of proteins. We tested starch as well. Starch will not contain any proteins. We tested grape juice, and grape juice again did not give us any proteins. And finally, the last sample was an egg solution, obviously very similar to our positive control, and these two both indicate the presence of proteins and almost similar amounts of protein in them. So we're done with the protein test, guys. I'm going to keep these on one side. We're going to now look at the starch. We're going to look at testing for the presence of starch, and we're going to look at testing for the presence of lipid. The starch test is quite easy because we're going to use iodine, but the lipid test required some prep work, which I did when I was at the lab, but I'm going to obviously show you how to do the experiment. I'm going to show you the results, and then we move on to the starch test. So I'm going to just leave these aside for you guys for a little while so you can have a look at it when we get back and when we interpret these results after the break. In the meantime, I'm going to put these in front, and these are the test tubes that I was working on at the lab. So essentially we're going to test for the presence of lipids, and this is not a color test. This is a test where we emulsify the lipid in a substance. We treat it with ether, guys, and here we have ether, and this is a volatile flammable substance, and hence it needs to be, and I've got my bottle labeled with red, which means that it is flammable, it's dangerous. You never work with that around an open flame. You know the possible dangers of that. So it's volatile, can easily spontaneously burst into flames, and you've got to be very careful. So whenever you see ether or any alcohol, guys, you've got to be careful that there are flames that you work, there's no flames around, and that the windows around you are open and there's lots of ventilation. Okay, so I've got different food samples here, guys. So I've got some pecan nuts here, I've got some almonds here, and I've got some normal peanuts here. And what I've done is, when I was at the lab, I crushed these up and I created a powder of these. So I used a mortar and pestle, guys, and I ground this up, and then it took me a little while, but it was a little workout, and I've created little test tubes or little containers filled with the extract that we need to test. So these contain pecan nuts, we've got peanuts, and we've got almonds, and we're going to test for the presence of lipids in these. And guys, and I'm sure you've watched this and you've seen your teachers and you heard your teachers talk about the importance of nuts and grains in our diet, and today we want to establish why. So definitely they have lots of proteins, but also are they good in the sense that do they contain important fats? And we know that there are important fats like the omega-3 fatty acids, and there's some good fats and bad fats. So today we're going to look at samples that we've tested. I also have margarine in here, guys, and if you know what margarine is a fat as well, and we have that with our bread, and so it's very important to know what is the amount of, or the concentration of lipids in there. So very quickly to touch base with what we're testing. We're testing for the presence of lipids, and we're using ether. And this is quite a simple test, guys. What we're doing today is we've grounded the lipids, I've grounded the nuts, I then will place them, I've got test tubes, I'm going to grab a test tube very quickly, one behind me here. I'm going to grab that for you, place this in front. So what we've done is we're going to add in a sample, and in this case we're going to add in a bit of the almonds. Okay, so I put in almonds in there, and I'm going to use a bit of oil, which we have right here. I'm going to drop in some oil into this test tube here, and we're going to test for the presence of oils in this. And remember that I said that this is not a color test, this is an emulsion test, so we're going to look at droplets, and it's very simple. And I'm sure you guys remember in India probably while having lunch over studying, and you probably dropped a crumb or piece of bread on your books, and you often end up with an oil stain, and you submit that assignment and your teacher says, wow, you've been having lunch with your work. And essentially that's what we're going to do today. So these will then be treated with ether. We're going to put in some ether into each one of them, a little, guys. So ether will, remember that your fats are soluble in ether, and this will break up the ester bonds that hold the building blocks together. So we're going to give this a gentle stir, and we're going to leave it to settle for a little while. And what happens in the meantime is that the ether will react with the fat molecules, and it'll split them up. Okay, it'll separate the glycerol and the fatty acids from them. We then will look at, I'm just going to turn this around so you guys can see this better. I'm going to move this to the front, and here you can see what's going to happen. So this should settle for about half an hour, and unfortunately we don't have half an hour, so I've done this prep work at school, and I've used these test tubes. So here we've got more of these test tubes that I've allowed to react with the ether. Now I'm going to give them a gentle stir a bit. I'm going to explain to you exactly what we have in each one of them so that you understand how the results come out. Okay. So what we have here is, in the first test tube we have water. In the second test tube we have peanut butter. In the third test tube we have margarine, we have milk, and we have pecan nuts, which I ground in an egg solution. And also right here, guys, I've used a test tube which is oil. I'm going to place this right here in the front because I didn't have enough place on my test tube rack. But this is oil, and if you know that oil is our positive control, so there's oil, our positive control, which will definitely indicate the presence of a fat in it. We have water, which definitely does not have fat, so these are our positive and negative controls which we're going to compare results to. So on a piece of filter paper, guys, I've divided the filter paper into different quadrants, and I've labeled them. And this is what essentially you should be doing. So you divide your, so I've got, there's 7 samples. So the first sample is water, the second sample is nuts, milk, oil, And if you move on to the next sample, guys, that's eggs, peanut butter, and margarine. So what I've done now is I'm going to place these in front, and I'm going to take a drop from each one of these. I'm going to take the drop and using a dropper and put a slight drop into them. And what's going to happen is, because ether is volatile, we're going to pick up some of the lipids, we're going to drop that onto the filter paper and hope that the ether evaporates, and we've got a good breeze in the studio. We hope that will evaporate quickly and we'll get results. Okay, so I'm going to go with our positive control first, which is I'm going to take a bit of the, okay, so dropper plays hard to get, he's stuck in there. Here you go, come out. So that's the dropper. I've taken a drop, and just a small drop, guys. You've got to take a drop of that. I'm going to take a drop, and I'm going to drop that right in the middle somewhere. Okay, then I'm going to move on to, let's see. So that was water, sorry. So I must put the water in the wrong place. So that's water. Okay, that's water here. That goes in there. Okay, they can see how thin that runs. And there's oil, guys. So I'm going to put oil back in here. Okay. Then I'm going to move on to peanut butter. Okay, that's nuts. So let's see, where's our nuts? There's it here. So that's the nut. Okay, so there's our nuts. Okay, we're going to drop a nut. Oh, too many. Obviously that's, and then we've got the next sample is milk. So we're going to milk here, guys. Okay, let's, oops. Okay, we have milk here. Okay, so you can see a little drop of milk in there. Okay, so we're going to leave this to evaporate and dry a little while. And we're going to move on to the next. So we've got peanut butter. Okay, so here's peanut butter, guys. Put a little drop in there. Oh, too many. We've got eggs. And remember that experiments always don't go as planned. And that's why a scientist will always repeat his experiments to get the best possible results. And that's part of doing an experiment. You can never get it right the first time, no matter how good you are at it. Okay, and here's margarine. And I'm going to put a drop of margarine on there. Okay, and I'm going to let this also evaporate and see what happens. So we've done that, and as I said, I was at school and I was busy doing this, and I'm not too sure if Wilson's going to zoom in on this, but Wilson's the cameraman, and I've asked him to come in and zoom in on the results here. So what I'm going to do is I'm going to place the results that I worked with already at work, and here we've got a series of templates. And if you look carefully, guys, if you look at, this is the sample from the peanut butter, and you can clearly see, if I hold this up, guys, you might be able to see some translucent spots. So an oil mark, here we can see in egg we've got a bit of oil. In margarine, guys, you can clearly see a nice ring around, okay, a ring around the margarine, and obviously that means that that's the presence of fats. We're going to look at our positive controls. I'm going to move this over. So we had oil. Okay, so there's oil here, guys. And that's oil. If you look at oil, you can clearly see that's a shadow, but you can clearly see a little water mark there, and actually it's an oil stain, and that indicates the presence of oil, or the presence of lipids in oil sample. When we look at water, guys, I'm going to move there's nothing in water because we know that water is pure and does not contain any fats. We're going to look at the nuts, and when I looked at this carefully, guys, I'm not too sure if you can see this, but there is a little area here that stains with a lipid mark indicating the presence of oils. In milk, guys, remember that the cream in milk is obviously a bit of fat, so you can see some, so you get low fat milk, you get 2% fat, and you get 0% fat. So here is a sample of milk, and obviously that contained fat, and you can clearly see the stain, the emulsion on this here. So we've worked on the lipid test, and we've looked at the presence of lipid. When we get back, we're going to look at the test for starch, and that's a very quick test. And after that, we're going to look at the results of all these experiments and how we tabulate them. So, Indy, from my side, we're going to have a very quick break, and then we're going to get back to the experiments.
Fantastic. Okay, guys, if you have any questions, please post them on our Facebook page, facebook.com/learnextra, or tweet us at learnextra, and we will answer them for you. Don't forget that the only silly question is the one that is asked after the exam, because then it's just too late. Don't forget to post your random acts of kindness on our Facebook page. It could be anything, and you could stand a chance to win some awesome, awesome prizes. See you now after the break. Hi guys and welcome back. I hope you enjoyed your break. I hope you're all refreshed and ready for some more of Eugen's amazing experiments, which I'm loving. I'm very glad there hasn't been a huge explosion as of yet. He keeps promising, but we'll have to wait and see. Okay, Eugen, I think it's
Thanks,
time
Indy.
to take it away.
I think it's time to blow this place up.
Ah, no, don't.
No, just kidding, guys. Okay, we've got to learn for the rest of the year, and we need this. Okay, so we looked at the test. We looked at the results from there, and we looked at the emulsification of fats. So we looked at watermarks or the oil stains there. The last test we're going to look at today is the starch test, and the reagent we're using or the indicator we're using is iodine. And iodine is a chemical indicator found in most labs, and again, that's the standard indicator for using when we're testing for the presence of starch. Now, starch, guys, just to remind you, starch is a complex carbohydrate, and it's not like glucose, which is a simple carbohydrate monosaccharide. So hence, we cannot use the same reagent that we used when testing for the presence of carbohydrates or when testing for the presence of glucose to test for the presence of starch in food samples. So what I have with me, what I have in front of me today is I've got a few different, and potatoes, and we've got some onions, and we've got apples, and again we've got some of your favorite peanut butter, and you know why it's good. We're going to test to see whether these food samples contain starch. Okay, so on this tile, this is called a spotting tile. And again, this is a very simple experiment, guys. You could do it. All you need is a dropper and a bottle of iodine, and you're going to test your different samples. Again, iodine is a bit corrosive, but as soon as you get onto your fingers, you rinse your hands, and everything should be fine. If you do have a problem, and then it persists, then you make sure you go and see a medical specialist or somebody who can advise you accordingly. So on the spotting tile, guys, if you look very carefully, I've labeled these different wells. So these are called wells, and essentially we're going to put in the different samples into these wells, and we're going to drop in a few bits of iodine, and we're going to look for color change. Again, the first one is starch, and again, that is the positive control, and the next well is water. During the break, Indy said that somebody probably posted a question on why do we need to have a control, or what is the function of a control. Remember that having a control is important, because you know that water does not contain starch. I mean, if we were drinking water every day, we know that it would not contain starch, and hence we use that as a positive control. Often in a lab, we would use distilled water, and that is 100% pure water, does not have any other nutrients and vitamins in it, and hence that would be an ideal control mechanism, a control test tube to use. So we use water and a positive control so that we can compare the negative test and the positive test to other samples. The question is, what if we didn't have a control? Then we would not be able to compare. And that's essentially important when you're doing any experiment, to have a control so that the experiment is fair and your results are reliable and accurate. So I'm not going to do any more talking. Let's get busy. And that's what it practically is about. So I'm going to just lift this up a bit. I'm going to elevate it a bit so that you can see exactly what we're doing, but not too much, because we're going to get a bit of these drops going through. So the first well, guys, is starch. So not too much. We're going to put in a little drop, and we're going to try and make sure that we don't contaminate the other wells, or else the results will not give us the accurate results that we need. So that's starch, few drops in there, guys. Then we're going to look at the next one is water, and there's water here. Yeah, I'm going to try and get in some more water here. Very little, not too much. Okay, whoops, just enough. Okay, and then we've got grape juice there, a bit into that. And unfortunately, I'm not going to be able to lift this up for you guys because it's going to spill, but I'm sure if we need to get closer, Wilson's going to zoom in, and he's going to give you a good eye of this. Okay, so we got milk. Okay, we've got milk in here. We haven't labeled milk, but I'm going to put milk right here just for you. We've got apple, so we're going to cut a piece of apple here, guys. And I know that apple's your favorite fruit, and you know why? Because it contains lots of glucose. So we don't know if it contains starch yet, but I'm going to do an interesting test at the end, and you're going to be quite amazed with what apples contain, and actually when they're ripe, what they contain. So that's the apple that we got in there. We've also got to cut a piece of potato, and so I'm going to cut the entire one, guys, and I'm going to just take a small piece in there, and I'm going to put it in there. Okay, so that's that. Don't need a big chunk, you just need a small chunk there. We've got glucose, which we need to test, and that's glucose is, okay, grape juice, starch, glucose solution. Okay, there's it right here. Okay, getting myself confused now. That's starch in the glucose in there, and we've got a bit of eggs. We need to test the presence of starch in eggs, guys. And you can try various samples, guys. The more you try, the better your understanding of the subject would be. And you can try this at home. You can easily get iodine at a pharmacy, and you can try it out. Okay, and we've got onions, and I've brought onion intentionally because I know that Indy likes onions, and I'm not too sure she's probably going to have this at the end with the apple.
How did you know I love onions? Maybe it's because of onion breath.
And then obviously we've got some peanut butter, and that's actually Indy's favorite. Okay, so we're going to put a bit of that in there, and we're going
I
to
do love onions.
Okay.
It's actually the truth.
And
How did
actually,
you know? I was actually quite surprised.
The onions actually have a very good cooling effect on the stomach, and they also have lots of medicinal properties, and hence we have onions. And maybe it's not because it tastes good, it definitely doesn't taste as good as it does, but it obviously has very good astringent properties for the skin as well as for the stomach. So that's a very quick lesson in that. So that's what we've gotten. I'm going to very quickly put a few drops of iodine into this, and I actually want to show you. And we know that potatoes contain starch, but we got to try out in our positive control. So that's our positive control, and I'm just going to add in a drop in the positive control and the negative control. So I'm going to lift this up slightly, guys, and I'm sure you guys can see from home. Here we have starch. In the presence of starch, a substance will, if you look at this, guys, okay, I'm going to try this on here, on the potato. Okay. So if you guys can, I'm going to let it soak a bit, and then I'm going to turn it towards you so that you can clearly see. Okay, we often end up with spills, but that's fine. Here's a piece of potato that we cut, a potato that we cut through, and we can clearly see. If we look at the color of the iodine, the color of iodine initially, guys, I'm going to drop a bit of, I'm going to bring this closer towards you. Color of iodine here, guys, is normally yellowish brown. Okay, in the presence of iodine, in the presence of starch, iodine will turn a dark black or bluish precipitate, and you can see it's a dark color. And this would be the positive test. If we look at the different wells, guys, we can clearly see now color change, and you got to look very quick. So let's look at it in grape. In grape, no color change. Let's go to the piece of potato. So we obviously tested that, so that's a positive color. The glucose, standard glucose solution, again it remains yellowish brown, so obviously the absence of starch. Let's look at eggs. And what would you think? No starch in eggs, and we know that, guys. Here's the apple, and okay, I know you guys can't really see this. I'm going to try and lift this up as we okay, see, that's an onion, and interesting, you can see I'm going to show you that on a bigger piece, and that's peanut butter. Okay, and here you clearly see, I'm going to try and rub this in a bit so that we have a nice color. So if you guys come, I'm going to try and move this around and come right close to the camera so that you can see this a bit better. Okay, so right here in front of me, guys, we see we've got starch, we've got potatoes, we've got apples, water, glucose, amino acids. And if you look carefully, you see the peanut butter has turned black, the onions have got some spots of black, the apple as well also contains starch. Here's the potato, which is tested positive. So of these samples, peanut butter contains starch, your onions contain starch, apples a bit of starch, potatoes definitely tested positive, glucose does not contain starch, your eggs do not contain starch, and your grape do not contain starch. So we've looked at these here, and as I wanted to show you the experiment with the apple, I'm going to show you very quickly what happens with the apple. Okay, so if we were to cut this apple into half, guys, and clearly see this here, okay, and if we do this, and this was a question that I set in an exam, and I asked the boys, why is it that, well, I teach boys, and hence I use the word boys, but I asked the learners, guys, why is it that when we test for the presence of starch in apples, the color would test positive? Now, the presence of starch in apples would indicate the sweetness of the apple. So when we look at apples as they mature, apples would initially have lots of starch, and as they ripen, the starch would be converted into glucose, and that is how they taste sweet. And hence, you'll find that here we have a positive test indicating that lots of starch in apples. And as the fruit ripens, it becomes sweeter, and hence you have the sweet taste. So we've looked at starch, we've looked at the presence of starch in different food samples, and now we're going to go, I know we have a minute or so, but we're going to very quickly go to the board, and we're going to look at some of the results that I've tabulated for you. So and that's the important thing about doing an experiment, guys. So we're going to move to the board, and we're going to look at results. So the first test we looked at was glucose, and with the reagent we used for glucose was, guys, if you remember, it was Benedict's reagent. So that was Benedict's reagent, and so I'm going to very quickly move on to the tabulation, and that's important. These are the results that we saw. So we saw that glucose tested positive and fructose tested positive. So it's your fruits that tested positive. Okay. When we look at sucrose, now sucrose is a disaccharide. A disaccharide meaning it's made up of two monosaccharides. It will not change color with the presence of Benedict's reagent. Because glucose and fructose are reducing sugars, your sucrose is not a reducing sugar. So in order for us to test whether a substance contains glucose, we will need to hydrolyze it using hydrochloric acid. So hydrochloric acid return. So we're going to go in for a little break. I'm going to show you the results after we get back from break.
Okay, guys, we're going to have a little break. Like Eugen said, make sure that you are following along with the notes, because the notes are so useful. They've got all of the pictures, they've got all of the questions, and it's fantastic to have, especially to work through while we're going along. And what we'll do, take a little break, and we'll see you now. Okay, guys, we are moving into the last section of our show, so if you have any questions, now is the time to ask. And if we have a little bit of time at the end, I will ask Eugen if we can go through them and help you guys out, and also help each other out on the page, guys. You know how it works. This community is not just for us, it's also for you guys too. Keep your eyes peeled to the page. We do have an amazing competition on at the moment, and it's all about showing your love this month. And SAPs are on. Please tell any mindsetters that are rewriting their grade 12 that they can tune in to 319 in the mornings for all of their SAPs revision needs. I will post a little link to the schedules and all the show notes and everything you need to download, but as long as you remember that you can speak to us on the page and you can go to our website, you can email helpdesk@learnextra.co.za. We are here to help all of the learners of South Africa. Okay, I think let's finish off this lesson, Eugen.
So thanks, guys. We're going to go into the last session, and remember that I always emphasize the importance of having the correct process when you're doing an experiment. So before you start doing an experiment, guys, I had to do lots of prep for this. And likewise, whenever you do an experiment in school, your teachers prep for the lesson. And likewise, when you're doing an experiment, you've got to know exactly what you're doing, and hence you need to have read through the instructions first. And this is what I encourage learners to do, to first start writing out an experiment using the scientific methodology. And that's simply having an aim, the method, and the materials mentioned, so that you know exactly what you're doing during the course of the experiment. So the aim for our first experiment was to test for the presence of glucose in different food samples using Benedict's reagent. And so we put down the reagent and we looked at the different materials and apparatus that we had. And I made sure that before I start the experiment that I had all these, and that's how I could do my experiment. I then wrote out the method, and that method described exactly what I was going to do, the exact quantities that I needed to use, and what I would and how I would need to label my test tubes. And that's how I prepped my test tubes, so that when I did the experiment it was easy, and I could easily now look at my test tubes and make a call about the results. So we looked at the results, and these are images about test tubes and the positive color that you would get in the presence of glucose. Here's the observation table. So I'm going to very quickly reach to the test tubes that we used for the glucose test. And I know that it's been a little while since we started, so we've gone through 4 experiments, so you're probably a bit confused now, but that's why I've got these test tubes. So we looked at the glucose solution in the Benedict's test, and we heated it. Before heating, guys, most of the test tubes were blue, and we hadn't anticipated color changes yet. And remember, when we saw the color change, we said, wow. So there's the red, and that's the positive color, and hence we said, yes, there is glucose present in the glucose solution. When we tested for water, we saw that it remained blue, and here you can clearly see it remains blue, which indicates a negative test. And so on. We went into grape juice, and yes, grape juice does contain glucose. Milk, guys, does contain, so it remained blue, no glucose. Starch solution remained blue, and hence no glucose. And our egg solutions remained blue, which indicate that there was no glucose present. We're going to move on to the next test. And the next test was the starch test, the last test that we did. I'm going to leave this very quickly. I'm going to grab these here for us to have a look at again, and we tested for the presence of starch using iodine. And here we looked at the method. I wrote out the aim, the materials that I needed, and the method, and this was simply using a spotting towel and putting in droplets of there. We go on to and this is what you may often be asked to do, would be write on the positive test for starch using iodine. So iodine will change from a yellowish brown to a violet black color in the presence of starch. The negative test would be iodine remains yellowish brown, and as you would see in these little spotting wells here. And hence I also tabulated these results, and during my experiment I also took out some photographs of images that we used at our labs, and here you can clearly see the absence of starch, and here the dark purplish color indicating the presence of starch in the food samples. Okay, so here the image shows the iodine when a substance contains starch. We saw that beautiful dark violet color when we tested the potato. Let's move on to the next test that we looked at. Okay, the test for proteins, and that was the test that we used the Biuret reagent. Guys, I'm going to grab that very quickly for you. And remember that there are two reagents that we used during the Biuret test. It was there was one reagent we used during and that we tested for in different samples. I've got the results tabulated here, and this is the color again, guys. And you could see when you upload these notes, you can clearly see the colors. Here the intensity is not as strong on what I've indicated here, but you can see that obviously this is a dilute solution containing protein, and here in my hand I've got a concentrated solution having a high concentration of protein, and hence the dark purple intensity of the test tube. Okay, so I'm going to go down to the observation table that I'd drawn. So we tested protein solution, it tested positive, and hence we said purple color, yes, present. Water, no proteins, it remained, you can clearly see it remained blue in this case, and hence no purple, remained no proteins present. We moved into the next sample. So we tested all these samples, guys, and the positive test were yes, proteins in egg solution, yes, in milk, but we said it was less because if we looked at the milk, guys, it had a lavender or a lilac color, which is not as pronounced as what we expected. We move on to the last test we did was the test on lipids, and that was the emulsion test that we used. I know that at the end of this, guys, there's lots of nice revision questions, and it's important, guys, you can access these notes online. Indy will give you the link, and for you to go through these questions, remember that you got to answer these questions honestly and reflect on these experiments. You probably will try these at school. And for now, I'm going to chat to you guys next week. I'm going to hand you over to Indy for now.
Okay, guys, please make sure that you do download those notes, and the link is learnextra.co.za/live. I will post it all onto the Facebook page. Make sure that you have downloaded these notes. Everything that Jürgen has been showing you is all on that downloadable PDF. So please make sure you do download it. Print it out, copy it, give it to your friends, use it to work through the shows, which this show will be on YouTube in the next 3 days. That's how it works. Learn Extra Live comes on, and in 3 days' time, we upload it to YouTube. Thank you so much, Grade 10s, for such an awesome session. Grade 11s, don't you move a bit. You're up next. Same time, same place, next week. Bye, guys.